Okay, right. In question 4a, they say that use the diagram below to prove the statement that says the acute angle formed by a count and a tangent at the point of contact is equal to the angle in the alternate segment. So basically, we are trying to prove a time chord theorem. Now, in this case, they say that we are required to prove, we are required to prove that that angle is equals to that angle over there, right? So we are trying to prove those two angles being equals to each other. Now we're gonna have to do a construction. Now in this kind of a question, there's actually three ways in which you can actually prove the ten chord theorem. The other one, I'm just gonna try and show you two ways, but the first one that you can do, you're gonna do a construction of AOF. Now that construction is gonna go from A passing through O and going to F there. Now I'm gonna call that point there F. Then you're gonna connect B and F, right? So you're gonna basically connect B and F. Now what you're gonna do in the question, you're gonna say that diameter draw diameter AOF and join BF. I mean to say and join FB. I mean to say and join FB. So that's gonna be the construction, right? Now going to the proof part of it, I'm gonna call this angle 1 and I'm gonna call this angle A2. Then I'm gonna call that other angle there B1 and I'm gonna call that other angle there B2. So basically angle EAC is gonna be angle A1 and then angle ABC is gonna be basically be angle B2. Alright, now going to the proof, now I'm gonna say that angle A1 plus angle A2, it's gonna give me a 90 degrees, and the reason for that, I'm gonna say tangent perpendicular to radius. Right, now I can just say that A1 now is actually going to be 90 degrees minus A2. Alright, so now I can just say that A1 is going to be equals to 90 degrees minus A2. Now using a different color, I'm going to say that angle B1 plus angle B2 is also going to be equals to 90 degrees, and the reason for that is going to be angle on a semicircle. Alright, and then so basically B2 angle B2 is going to be basically 90 degrees minus B1 minus angle B1. Now to change a color, right? The other thing that you also gotta look out for now, it's gonna be that angle B1 and angle A2 they're basically equals to each other. The reason for that is gonna be angles on the same segment. Angles on the same segment. Now this means that if angle B1 is equals to angle A2, this means that angle B2 is basically going to be 90 degrees minus angle A2, right? Now I can now say conclude that angle A1, I was supposed to angle A1, right, is going to be equals to angle B2, and the reason for that, I'm gonna say both equals to 90 degrees minus angle A2. And then yes, that's how you can now actually prove that whole entire Tank theorem. Now the second method that you could have done basically the other method that you could have done, you instead of constructing line AOB and then connecting it to AOF, I mean to say, and then connecting it to B, you could have actually constructed line BOF and then construct it this way, and then you're gonna try going the other way to solve it. And then the other method that you could have done, you could have constructed line AO and OC. All right, so there's actually many ways that you could have done it. So you could have went the way where you could have constructed line AO and line OC, or you could have constructed line BOF that way and then connecting it this way. All right, but this is the one that I actually chose to go and prove that theorem over there. All right.